Alright, a lot of students ask me to make a video about relative velocity. So yes, today I'm going to use the simplest way to really explain about relative velocity, teach you how to do the exam question. But then in this video, I won't go until too deep about the theory about relative velocity. But then I will teach you the important techniques on how to solve the relative velocity questions in your IGCSE exam or O-level exam. Alright, I think this one might be the last chapters of your IGCSE. Alright, so yes, so on the relative velocity, something you have to really understand is the important rule. I'm going to call it velocity of the A will equals to velocity of A relative to the B plus velocity of the B. Alright, this is something they call it something like additional law for relative velocity. Basically, how I remember this law is very simple. Yes, you just see, okay, I based on the relative velocity. If this A relative to B, then the first alphabet is A, right? So I write equal here and then I write A here. Right? The second alphabet is B, right? So I plus velocity of B. Right? So this additional law tells us what? This additional law actually tells us that this one equals to this one plus this one, isn't it? So velocity of A in this case is called resultant vector. Alright, resultant vector, if you learn about vector, you know that resultant vector means two vectors plus together, we will get the vector A. Okay, so for example, if I want to show you what is the resultant vector, I will do like this. If this is the vector A, means vector of the velocity of A. So this one, the arrow is like this. So this one is the resultant vector, isn't it? So I know these two vectors plus together should get this vector. So the direction of these two vectors is very important. So maybe I randomly draw two lines. Alright, so let's say this vector is facing this direction and this one is resultant vector, right? Means this vector plus this vector should equals to this vector. Right? And these two can be, this one can be velocity of B, this one can be velocity A relative to B, or the other way around, or this one can be velocity of A relative to B, this one is velocity of B. Either one is correct. The important part is if this one is a resultant vector, these two vectors plus together must get this vector. So for example, if I give this one A, B, C. If A to B, if vector AB is a resultant vector, you imagine this is your home, this is your school. Okay, A to B is the shortest journey from your home go to your school. But then you actually can go from other journey to you can go from the other journeys to go to your school, isn't it? Alright, so you see A to B, you from home go to your school, but then you can from your home pass by C, end up you still go into your school. So this is the important concept about resultant vector. You must understand this one in order to solve the relative velocity, because the hardest part of the relative velocity is you must able to draw out the triangle. You must draw out the triangle correctly, then only you can find out all the velocity you want, means you can find out the answer. Because a lot of students have the difficulty in drawing the triangle. So I'm going to show you another example just to make sure you can understand this part. So for example, I write this velocity of B relative to A. So what I will do is I write equal here. This is B, isn't it? So this one is velocity of B. This one is A, isn't it? So I plus velocity of A. Right. So in this case, velocity of B is my resultant vector. Alright, so this one is my resultant vector. So if velocity of B is my resultant vector, this case tell me what? If let's say I just randomly draw a triangle and I just call this one is velocity of B. Okay, let's say velocity of B facing this direction. And velocity of B is a resultant vector, right? That means another two vectors plus together should get velocity of B. So in this case, that means if this is velocity of A, so the other one, the arrow should face here. This one is velocity of B relative to A, or the other way around. Or the velocity of B relative to A can be here, and velocity of A can be here. Right, so you see, this is your home, go to your school, isn't it? You can go from this way, reach your school also. But the important thing is, at the end, you must go into the school. Means the arrow must face here. If today, you just change your arrow face like this, the whole triangle actually is wrong. So the arrow is so important in this chapter. Yes, because in order to make sure your triangle is correct, because sometimes you have 2 or 3 ways to draw a triangle. So you might not sure which method actually is the best. Alright, but as long as you fulfill these 2 conditions, yeah, I think your triangle is acceptable. Right. So, okay, so this video I'm going to show you the Canon and Booth one first. Then, and on the next video, maybe I will do for the plane one. Alright, I mean for the aeroplane or for the aircraft. Right. So, okay, I got some example here, and then all of this actually I take from the past year question. Alright, so over here the questions give you a diagram, and then this is a past year paper 2-1 October November 2013 question number 9. Yeah, if you have the past year paper, you can actually go to find out this question. Alright, you got the diagram. Over here, the diagram says, the diagram shows a river with a parallel bank. So these 2 banks actually is parallel, and then the river is 40 meter wide, okay, it's given, and it's flowing with the speed is 1.8 meter per second. So something important here, you must understand this 1.8 meter per second, this one is the velocity of water, or you can say velocity of river, but normally I will use water. Alright, a cannon is traveled in a straight line from the point P on one bank to a point Q on the opposite bank, and 70 meters downstream from P. So basically, the cannon is going to travel from P to Q. So from P go to Q. So this one will be the velocity of the cannon, because cannon going to travel from P to Q. Alright, you must get the idea of it if you really want to solve this. Alright, then given that the cannon will take, can you see it? Given that the cannon take 12 seconds to travel from P to Q, okay, and then it asks you to calculate the speed of the cannon in the steel A. Alright, here got something important. Okay, the 12 seconds we're going to use it later. Something important here is it asks you to calculate the speed of the cannon in the still water. When you see in the still water, this one means what? They want to find cannon relative to water. So in this case, they want to find velocity of cannon relative to water. If I use C, stand for cannon. So when you see in the still A or still water, yes, you see the word in still. So that means they want to find this one. So they ask you to calculate the speed of the cannon in the still water. Alright, and then the angle to the banks, the cannon was still. So basically they want to find the angle for relative velocity also. Because when you see the cannon was still, means what is the relative velocity and how the relative velocity is still based on the bank. Right, so I'm going to show you more details very soon. Alright, so from here, this is the relative velocity I have because I say cannon in the still water. So it's cannon, water, right? So I have to write out my additional law. So I write velocity of cannon equals the velocity of cannon relative to water plus the velocity of water. Alright, then I will need more information because first I will need direction. Alright, the water, I have the direction already. Obviously, it's parallel to the bank. So it's something like it going to the east. Just velocity of the water is 1.8. I need the speed and direction. At least I need 2 information because here I got 3, right? And I will need at least 2 to find the third one. Alright, so over here 12 seconds actually plays some important role because what? We understand something like speed actually equals to distance over time, isn't it? We got 12 seconds here, this is time. So if I want to find the velocity of the cannon, I can easily get the distance because this is 70 meter, this is 40 meter. I can use Pythagoras and then I can get the distance for this one, and I got time, 12 seconds. So I can get the velocity for this one. Alright, so I'm going to find this one as well. So I'm going to say velocity of the cannon will equals to distance here is actually Pythagoras will be 70 square plus 40 square and then square root the whole thing. We're going to find the hypotenuse, isn't it? Alright, over time. Time is just 12 seconds. Alright, then I just press the calculator for this one. Yeah, in order to find the velocity of the cannon. So basically 70 square plus 40 square. And then we square root it. We basically will go 80.622 divided by 12. Yeah, so roughly I got is 6.72 meter per second. Alright, so now I got something here, this meter per second. I got the velocity of the cannon is just like 6.72. But I do not have the direction of the cannon. So I need to find the direction. Basically, I need to find this angle. Alright, so I'm going to draw out the right triangle over here. Oops, my triangle is wrong. Okay, just ignore this line. I'm going to draw a right triangle over here. And then I find this angle. I got this one is 70, this one is 40. I know actually I can use tangent to easily find because I got opposite over adjacent. So it will be 40 over 70. Then I press the calculator. Of course I will take the first quadrant answer because the answer should less than 90. So 40 divided by 70 and I shift tangent. Yes, fine, is okay. It's 29.74. Alright, maybe I call it 30 degree. Okay. Alright, now I got some direction already. It's 30 degree here. This is the velocity of the cannon, and then he's like 30 degree from the bank to the queue from Alright, so now I'm going to draw out the relative velocity. I'm going to draw out the vector thing using the relative velocity I have here. Alright, so based on the information I have, this one is my resultant vector from P to Q, isn't it? So my resultant vector is this one. Because of this rule, you tell me VC is my resultant vector. So I'm going to draw it. This is resultant vector. Mean another two vector plus together should get this one, isn't it? And then I got, okay, this is velocity of the cannon. Okay, then that means I can randomly draw two lines. This one I draw for water, maybe velocity of water, and maybe this one I draw for velocity of the cannon relative to the water. You must base on what you have here, cannon, water. So you see, if this one is my resultant vector, so these two vectors plus together should get this resultant vector, isn't it? Alright, so if I understand this one, then I can easily solve it. Right, so I got this one is 1.8, and then I got this one is 6.72. Alright, and then I got some angle just now. Because this line is parallel to the bank, right? Just now, this angle actually is 30 degrees. So I know I can use the alternative angle thing, so I know this is 30 degrees as well. Right, so I want to find the velocity for this one, will be very easy. I can use cos rule. Two sides and one angle in between, right? So the question asks us to find the speed, right? So yes, I will need to find the velocity for this one. So I can use the cos rule. Because cos rule tells us that if you have two sides and one angle in between, we can do something like 1.8 square plus 6.72 square minus 2, 1.8 plus 6, not plus, multiple 6.72 and then cos 30. And then I square root the whole thing. I hope you are not I hope you are familiar with this formula. This formula is the formula for triangle. You learn in your extended maths or your MX is something like a square equals to b square plus c square minus 2bc cos a. Alright, I hope you see this formula before. Alright, so then we can easily get the length for the for the velocity cannon relative to water. Okay, so I just press the calculator. 1.8 square plus 6.72 square minus 2 times 1.8 times 6.72 times cos 30, and then I square root of my answer. So I got the velocity of the cannon relative to water is 5.24 meter per second. Alright, now I solved the first one, which he asked me to calculate the speed of the cannon in the still water. That means I got it is 5.24. Then the question also asked, and the angle to the bank. Okay, so that the cannon was still. So basically what I want to find is, what is this angle? Alright, because a lot of students ask me about this kind of question is, if I have the relative velocity like this, means the cannon relative to water, I should find this angle or this angle, or I call it alpha 1 or alpha 2. Which angle should I find? This is the most student ask me about this kind of question. So you always find the acute angle, right? You find the angle less than 90. We never take the angle is bigger than 90, right? So basically I know I need to find this angle. So if I want to find this angle, of course I need to know what is this angle first. So since I have this one is 6.7 something, oh no, it's 5.24. It's 5.24. Alright, so I know I can actually use sine rule to find this one, isn't it? Alright, so I call it sine alpha over opposite length is 1.8 equals to sine 30 over this one, isn't it? Sine 30 over 5.24. So I can calculate alpha easily using sine 30. Yeah, sine 30 and then over 5.24 and then multiple 1.8. Alright, and then I shift sign, answer. Actually, I will get the angle is 9.9. Or I can call it 9.89. Right. Alright. If this is 9.89, so obviously you know this one should be bigger than 90 degrees, isn't it? So, okay, so means what? This angle is 180 minus 9.89 plus this one, so it will be minus, plus together is 39.89, isn't it? So, you 180, you minus 39.89, you got obtuse angle, which is more than 90 degree. Alright, but I say we never take the angle bigger than 90, right? So we take the other side, which is, we take this one, 39.89. Because actually the cannon will still in this angle. So we never take the angle more than 90. So over here I'm going to say is that the angle to the bank the cannon was still is 39.89. So this is the whole thing we want to find. So basically this triangle is wrong. If you want to know what the real triangle will look like, is actually I think it will look like something like this. Okay, this is, let me see, this is P to Q, isn't it? Okay, this one is P to Q. Alright, and then the other one should be like this. Alright, this one doesn't exist. This is velocity of water. This is velocity of the cannon. This is velocity of the cannon relative to water. So, yes, this is the angle they're asking for. Okay, we shouldn't find the angle is like more than 180 because just now we got this one is 140.11, but I will never take this one. I will take the angle is less than 90. All right. So I hope this question can give you some understanding about relative velocity. So I will try to discuss another question. Okay, about this one, about cannon also, but this time they just use the word boat. All right. So in this case, he said the diagram shows a river with a parallel bank. The river is 48 meters wide and is flowing with the speed 1.4 meters per second. So over here, I know something. This is velocity of the water, right? And then a boat is traveling in the straight line from a point P on one bank to the point Q on which is on the other bank, directly opposite the Q. So you see the 90 degree here, isn't it? And then given that the boat actually takes 10 seconds to cross the river, so I can get, so this is velocity of the boat, isn't it? Because it's going to from B, P go to Q. And then it gives you, actually use 10 seconds to cross this one. We know actually speed is equal to distance over time, isn't it? So we got 48 meters over 10 seconds, so it's 4.8. This is the speed. So velocity of the boat I just got now is 4.8 meters per second. Alright, based on this information given, because it's tell me 10 seconds sure with the reason. Alright, then of course I think I have second page. The question asks you to find the speed of the boat in the still water. So you see boat in the still water means they want to find velocity of boat relative to water. Alright, and then he asks you to find the angle to the bank at which the boat should be still. Alright, so basically they want to find what is the angle for the velocity of boat relative to water, but this one should base on the bank. And then like what I say, you always need to find the angle is less than 90. Alright, so over here I got all the information, and then I have to like draw out the triangle I want. So this is my resultant vector, velocity of the boat. So I mean another two angle plus another two vector plus together should get this vector, right? So I'm going to call this one is a velocity of the water because it's parallel to the bank. And then this one I draw like this. This is velocity of the boat relative to the water. Alright, so over here I know this is 1.4, and then this one is 4.8. Alright, so first thing over here is I need to find this one, but this is 90 degrees, so this question is so easy because we can use Pythagoras to get this one. It's just like 1.4, I write the equal here, 1.4 square plus 4.8 square, and then I square root of the whole thing. Because you can use Pythagoras when this is velocity and this is velocity, so this one you find definitely is velocity. So it will be 1.4 square plus 4.8 square. Then I square root of the answer. Basically I got equal to 5. Alright, now I done this one, which is the speed of the boat in the still water. It's just 5 meters per second. Then I want to find the angle that's still. So basically, if my drawing is correct, I need to find this angle. This is the angle that's still. Because this one should be less than 90 degrees. But then before I find this angle, I need to find this angle first. So I'm going to call it alpha. And then I got opposite and adjacent, so I will use tangent. So tangent alpha just equals to 1.4 over 4.8. Then I can find my alpha easily. So yeah, shift tangent 1.4 over 4.8. So basically I got 16.26. Alright, if this is 16.26, this is 90 degrees, isn't it? This is 90 degrees, so I can know this angle easily. Just use the 90 minus this angle, minus 16.26. Then I can know what is the angle that's still. So 90 minus answer. So I will got 73.7 degree. So this one, so you can like summarize like right, the angle to the bank at which the boat should be still is 37.7 degree. Alright, I hope these two videos I hope these two questions actually like give you some understanding about how the boat works. So before I end the videos, since I still have a little bit of time, so I might like put one of the planned questions as the last question over here. And then yeah, on the second video I will like discuss more about the relative velocity of the plane. Alright, so now I just add one more before I end the video. Alright, so because I think the plane one is like more famous compared to the boat one. Alright, so over here, alright, we got the question like this. So let us like digest the question first. Because for the plane one, actually you need to understand about bearing. Bearing must always start from north, and then you also, because on the plane one actually you want to get the direction, the only way you can get the direction is from the bearing. So you must understand about basic of the bearing. So over here, let us go through the question. A plane whose speed in the steel A. So you see speed in the steel A mean what? Speed in the steel A mean velocity of the plane relative to the A. Alright, A, I just write A equals to 240. Alright, this is first information I have. Flight directly from A to B is 500 km. So means from distance from A to B is 500 km. From A on the bearing of 32. So he said the word from A means the angle at A. So basically 32, roughly you need to get the idea what is 32. If this is north, 32 is roughly like this, 32 degrees. From A, isn't it? So this is A, B, and we know the distance over here is 500 km. So I'm going to mark down with different color. This is 500 km. Alright. So it's so important you know that bearing is always start from north and the angle is always rotate clockwise. You cannot like 32 from this direction like anti-clockwise, is wrong. Right, so he says the plane is actually flight from A to B, right? So this one will be velocity of plane. It's from A to B. Alright. Let me continue read this one. So there's a constant wind of 50 km per hour blowing from the west. So from the west, roughly I know the velocity of the wind is just 50 km per hour, and from west, blowing from west. Alright, due west and from west is very different. Alright, so this is the direction I have. Alright, so in this case, he doesn't give me the direction for the relative velocity. I know I have to find it myself later. Alright, find the bearing on which the plane is still. So when you see the word is still, mean you want to find the bearing of the relative velocity, which is this one. You are not finding the bearing for the plane. Alright, it's the plane in the steel A. Alright, so you must understand when you see is still or the cost is set, something like this, you know that you have to find the bearing for the relative velocity. Mean this one. Alright, so before I want to find, of course I always need to draw out the triangle first. So from here, since this is my resultant vector, so I know another two vector plus together should get this one. So I just actually I can add the velocity of wind either here or here to get this one. But because of space issue, maybe I'm trying to add here. See, will it make a huge difference or not? So this arrow should face here because this is resultant vector. So this vector plus this vector should equals to this vector. Alright, so yeah, this one fixed already. This is velocity of the wind is 50. And velocity of the plane relative to A is 240. Okay, this is not speed, this is distance, so you can't use this number. Unless all of this one is distance, then maybe you can use this number. Distance and speed is totally different thing. So from here first, I need to get more information first, because inside my triangle I do not have any angle. So what I will do is, I want to find this angle. It's easy, because it says from west, right? This is north. North to west is 90 degrees, so this one should be 58. Okay, now I got this one. Alright, then I want to find the bearing for this one. So basically, I want to find what is the total bearing from north to here. So I need to find this angle, isn't it? So, but before I need to find this angle, I can't find because I got not enough information. My sine rule is like A over sine A and B over sine B, isn't it? No, so B over sine B and A over sine A, isn't it? So I can find this angle first. I'm going to call it alpha. So in this case, I'm going to do something like, I want to find this angle, because triangle, I minus these two angles, 180 minus these two, I can get this one. So I'm going to call it sine alpha over 50 will equals to like sine 58 over 240. I hope you're familiar with the sine rule. Right, so you just press the calculator for this one. So like sine 58 over 240 and then multiple 50. And then I'm going to shift size answer. So I got this one actually is 10.18 maybe. This is the angle for this one. So I can get this angle easily using 180 minus these two, isn't it? So I call this one angle equals to 180 minus 58 minus 10.18. Alright, so 180 minus 58 minus 10.18. So basically I will got this is 111.82. Alright, if you want to find the bearing of your steel, so you know this is more than 90 degrees. So first thing come into your mind is this triangle doesn't make sense because this one seems like acute angle less than 90. So you need to redraw the triangle, because when we draw the triangle, we do not know whether this is correct or not. We just like using the additional rule just now I show you to like randomly draw out the triangle. So because you need to find the bearing, you cannot, of course you can still use 360 to minus this one, but then you will got it wrong. So I'm going to redraw the triangle over here. Of course this one is correct. This one 32 degrees, this is correct. This is from A to B. But the problem is this is more than 90, so I think this line should go somewhere here. So I'm going to like do something like this, and this one should go somewhere here. Oops. So this line should be like this. Right, so let me just take a new paper to draw it nicely to give you more idea on how to do this one. Alright, so in order to make that one is roughly 110, so I'm going to draw again. This is 111.82. Alright, so this is A to B should look like this. Of course, this one doesn't seem like 32, but it's just an example. This is north, right? So this one will be north also. Alright, so this is A to B. Alright, so now this one is the right one. After I find out all the angle, of course I know this is 58, and this is just a 10.18. 10.18. Alright, so now you want to find the bearing for this one. So bearing, the direction play a very important role, because now this arrow face here, isn't it? Because this is resultant vector. So if the arrow face here, your bearing should always from the north here. So here is 90 degrees, isn't it? So from the north here means you have to find this angle. So you want to find this angle, this is the bearing. So you know actually you have to use 90, this one minus 90, right? So the bearing still I'm going to use 111.82 minus 90 degrees, because I want to find this angle only. So which is 111.82 minus 90, which is just 21.82. Because bearing must always from the north, because this line already go until 110. So 110 already like over the north already, right? So you have to like really draw it out in order to see the bearing. This is important. Right. Okay, then I use the new diagram to solve the rest. Okay, the second part. The first one he asked me to find the bearing which the plane is still, so I find already is 21.82. But for bearing, always must be 3 digits before the decimal. So I'm going to write 021.82. Alright, the second part, he asked you to find the nearest minutes. So you're going to use minute later. So hour you have to change to minute. The time taken for the flight. So you want to find the time taken for the flight. So of course just now we got some information. This is velocity of the plane. This is velocity of plane relative to the A is 240, and velocity of the wind is 50. So that means if I can find the velocity of the plane, I got the distance, what? So I can use distance divided by speed to get time, isn't it? Because I know speed equals to distance over time. So time will equals to distance over speed. So basically I got distance is 500. I need to find the speed of the velocity of the plane. So that means you can either use cos rule or sine rule, because you got 3 angles already. So let's say we use sine rule again to get this one. So I'm going to call it velocity of P equals to opposite angle is this one, sine 111.82. Alright, and then equals to, I take this one maybe, because I want to get velocity, right? So yes, 240 over sine 58. Alright, I can get the velocity of speed easily. Just use this method. So it's just 240 divided by sine 58. Okay, multiple sine 111.82. Alright, so I will got the velocity of the plane is 262.73. Alright, this is km per hour. So now I got the velocity and I got the distance. So I want to find time easily, just 500 km because it's given here. 500 km over the speed is 262.73 km per hour. Something you must pay attention over here is the answer you find is actually in hours. So later you have to convert to the minutes. So you're going to say 500 divided by answer. I can easily get this one is actually like 1.9, yeah, 1.9 hour. So I want to change into minutes. I just multiple 60. So it's just 114 minutes. Done. You don't need to like convert to the second also, but because it asks for minutes, so I just change this one to the minutes. Right, so just hour multiple 60, you can get in minutes. Right, I'm going to make another videos. Yeah, it's more on the plan. And then actually for the relative velocity, you go through the past year, you got another type which is include the column factor one. He will tell you like due north is actually is J and due east actually is I, something like that. And then yeah, he asks you to find the relative velocity. And then also I will see one question in the past year is talk about the intercept one. Mean actually another boat is going to save the other boats, something like that lah. So I will try to like squeeze all of this in the second video or second and third video. Right? Yeah. I hope you enjoy the video and I hope at least you learn something from my video. Okay. Bye.